So now we're at chapter 3, section 3, where we're proving lines are parallel. So this is where some of the prior stuff that we talked about, like conditionals and converse, are going to first come into play here. So let's just look at the converse theorem that is presented in front of us. It says corresponding angles converse theorem. And it says that if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. And so this sounds very familiar to the corresponding angles congruence theorem, and so we need to talk about that. The original theorem, right? We had a theorem that said corresponding angles congruence theorem. And the original theorem said if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So if you notice, the hypothesis here is if two parallel lines are cut by a transversal, let me move this over, okay, and the conclusion, or remember that our hypothesis is always in red, and remember that our conclusion is then the corresponding angles are congruent. So this is a traditional conditional statement. It's an if-then statement, and if one thing happens, then the conclusion is the other, okay? So again, the given is the if part. If two parallel lines are cut by a transversal, then you can conclude that the corresponding angles must be congruent or are congruent. The corresponding angles converse theorem reverses those, okay? It basically says that if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. Notice that you're not given the parallel part. The parallel part is actually the conclusion that you drew. So they basically flipped the original corresponding angles theorem. They did the converse. They said if Q, then P. So if the corresponding angles are congruent, then the lines are parallel. And so it's the converse of it. Again, when you understand how in original conditionals and converses work, this should make sense. So again, here, the given is that the corresponding angles are congruent. The conclusion is that the lines then must be parallel. So if I'm looking at this picture and nobody tells me that line J and K are parallel, I can look at the corresponding angles and see if they're congruent. Notice they each have one tick mark, which means they're congruent. And therefore, because angle 2 and 6 are congruent, then I can conclude that J and K are parallel. So because, basically, the corresponding angles are congruent, angle 2 is congruent to angle J, or angle 6 rather, then line J and K are parallel. And so again, it sounds like you're saying the same thing, but it's totally different. The given and the conclusion are completely opposites. And so guess what? All the other theorems that we learned in 3.1 or 3.2 rather, now we're going to have converses to all of them. So again, here now it says the alternate interior angles converse. Remember, the original said that alternate interior angles, if two parallel lines are crossed by a transversal, the alternate interior angles are congruent. So this one is saying that if two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. So this whole section is really proving that lines are parallel by looking at those different angle relationships and seeing if we can prove that. So again, we go to the third one, alternate exterior angles converse. If two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. So again, you have to know in parallel lines how those relationships are. Remember, corresponding angles are congruent, alternate interior are congruent, alternate exterior are also congruent. The only one missing and we added it over in this slide, is the consecutive angles converse. And this is the one, this is the same side interior. And remember that this is the one that's a little bit different, because this is the one that says that it talks about, instead of being same side interior angles when the lines are parallel, these are supplementary or add up to 180 degrees. And so here it's saying that if two lines are cut by a transversal and the consecutive interior angles are supplementary, or like we know, the same side interior angles are supplementary, then we can conclude that the lines are in fact parallel. Here we're going to apply our transitive property to parallel lines. And let's start with a line J. Okay, and what we're going to do, let me label it right, lowercase j. So I have line J, and I have a second line over here, and I'm going to call it line K. And line K is parallel to line J. So line K is parallel to line J. And then I'm going to create another line here. I'm going to call it line M. And I'm going to say that line M is parallel to line J. So if I happen to have a line K is parallel to this one, to line J, and M is parallel to this one, then I can say that these two lines are parallel to each other, okay? So I can conclude that K is parallel to M as well. Now, how could I write this a little bit better that looks more like the transitive property? Because I kind of made a mess of it, right? Let me do it in the proper order. Let's say here, I'm going to do line K is parallel to line J. Line J is parallel to line M. And therefore, line K is parallel to M. Notice I basically cancel the middle. Or I can write it like this. K is parallel to J. J is parallel to M. And therefore, I can cross the middle and I can say that line K is parallel to line M. Okay? And so again, if two lines are parallel to the same third line, then those lines must be parallel to each other. So how can we prove that two lines are parallel? Well, we just learned all these theorems and ways to do that. So the first way we can do it is we can try to show that a pair of corresponding angles are congruent. Once I can show that the corresponding angles are congruent, then I can conclude that the line is parallel. This would be the corresponding angles converse theorem. The second one, I can show that a pair of alternate interior or alternate exteriors are congruent. So this would be alternate interior converse theorem or alternate exterior converse theorem. Again, it depends on if I'm given interiors or exteriors. Okay. Number 3, I can show that a pair of consecutive interior angles are supplementary. Again, these are my same side interiors. So this is my consecutive angle converse theorem. And the last one, I can show that both lines happen to have or be parallel to a third line. This is actually the transitive property of parallel lines. So the things that we talked about here, these are, again, a summary of it. So when I go here and they want to know which segments are parallel, well, I got to start by looking at what can I prove? What can I identify? So what I'm going to do is I'm going to look at here my different things. I notice, first of all, that I have this large angle here, right? Angle CAB, if you will. And I know that using the angle addition postulate, I know that this large angle here is the sum of 24 and 36 or 60 degrees, okay? Which might matter, I'm not sure, okay? And then I know that this large angle over here is also going to be the sum of, using angle addition postulate, 22 and 38, which is also 60. So now I want you to see, okay, those angles are the same. I want you to think of it as this is a line, this is another line, and this green thing here is the transversal. And so I'm trying to understand that 60-degree angle, what relationship is that? And notice that this big angle here and this big angle here are technically corresponding angles. And since those two corresponding angles are equal, I can prove that this line and this line are parallel to each other because the corresponding angles are congruent. So in this one, I know that, for example, line AC is parallel to line BE because of corresponding angles converse theorem. So I was able to find that those two lines are parallel. Now, the next set of lines that I'm trying to figure out are parallel, right? The only lines there, I'm trying to figure out if this one, so I got this line here, AD, and this line here, BF, and again, I have this transversal, so I know that my corresponding angles would be this angle 36 and 38, and notice that those are not equal. So because those corresponding angles are not congruent, I know that AD and BF are not parallel lines. The next question says, what value of x makes AB parallel to CD? So first let me find AB. Here's AB. Here is CD. And what does x have to be to make it parallel? Well, again, I'm going to notice that what they've given me is they've given me this angle here and this angle here together. Both of those angles, I mean, it's kind of like here and here, they have to be congruent. They're corresponding angles. And if they're congruent, my lines are parallel. So if x plus 40 equals 90, then my lines are going to be, then AB is going to be parallel to CD. So since I know this, then I'm just going to figure out, well, what value of x makes that happen, right? Subtract 40, and then if x equals 50, then the lines are parallel. So what value of x makes this happen? 50. And so that's how I solve that one. When I come over to example 3, it says find the value of x and y that make J parallel to K and L parallel to T. So again, I'm going to go slow here. I'm going to start with J and K. So here's J, here's K, and here is my transversal. So I recognize that this angle here and this angle here are corresponding, and they must be congruent if my two lines are to be parallel. So to prove that J is parallel to K, I know that 3x must be congruent or equal to 60 degrees, so x must be 20. So if x is 20, then I know that J will be parallel to K. So that's my first thing. Then I have to go through, and now I have to prove what will make L and T parallel. Well, again, I come over to here for consistency. Here's line L, here's line T, and the transversal that's going to affect Y is this one, right? And then I notice that 2Y and 60 degrees, those two angles are alternate interior angles. So for L to be parallel to T, 2y must equal 60 degrees, which means y must equal 30. So these are the two values for x and y that I have to have for all those pairs of lines to be parallel to each other. And lastly here, there's a question with like a real world thing. It says snake patterns. How can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake? Well, again, it's very hard to see in that first picture, but if you notice in the second, they kind of did this red line here. I'm going to extend it out. They did this other red line here, and they cut it by a transversal here. And when they cut the transversal, they have this angle and this angle. Well, how are they going to know if they're parallel? Well, those two angles must be congruent. Those two angles are alternate interior angles, and for them to be parallel, they must be congruent. And again, we don't have enough information to do anything else, but they must be congruent for that to happen.